So quantities that have only magnitude, mass, volume, time, speed. Time is vector or scalar. Prove it if it's vector and you may get a Nobel Prize for it. Quantities that have magnitude and directions are basically vectors. You know what that is. I'm not going to dwell over it because you've done it in your school and college. Vector addition. You know, vector addition, same vectors, vectors in the same direction add up, vectors in opposite direction, they subtract. You can even multiply a vector with a scalar. So its magnitude increases, its direction doesn't increase. There's no such term as increase in direction. Okay. So if you got a if you got scalar, a number being multiplied to a vector, you cannot increase the direction. Okay, there's no such term as increasing decreasing direction. So common sense tells us that if you got a number multiplied by a vector, only its magnitude will change. You can increase or decrease magnitude. There's no such thing as increase or decrease direction. Okay. So you got, this is for you to go through. Basically, addition of vectors, simply add the vectors, vector subtraction, difference between two vectors, product of vector multiplying a scalar with a vector is the product. If the scalar is in decimal, so it means you're dividing the vector. If like 0.2 or 0.3, if it's 0.5, you're basically, if you multiply 0.5 by a vector, it means you're dividing the vector by 2. So it's the same thing. Okay. And you've got some of the examples given here. This is the vector where you've got vector A, and the minus A is basically the same magnitude but in opposite direction. You've got vector A here, and it's been multiplied by 2. The magnitude has increased. It's been multiplied by minus 1.5. Its magnitude has been increased by 1.5, but because you've got the sign of negative, it's in the opposite direction. And then you've got 0.5a. Basically, you divided your magnitude by 2, and you have reduced the vector.